Hello everyone. So in this question, we are given some of the statements and we have to find which statements are correct statements. Okay. So these are the four options that are given to us. So these statements actually are giving the information about the, you can say auto variables and some static variables, register and global. So this question is something similar to your storage classes. So for this question, you should know about what are the storage classes and how they works, what are local and global variables. So I will start the timer and you can pause the video, you can read the question and then you can find the answer first by yourself and then we will understand the correct answer. So I hope you have got the answer. So the correct answer for this question is option D. So that means out of these four statements, no statement is correct statement. All are false statement. So let's understand all these statements one by one. So first statement says auto variables present inside a function, they are not stored into the stack. So let's understand what are auto variables and why this statement is actually false statement. So here you can see we have a simple example. So here we have written int main. Inside int main we have a variable a. Okay, and then sample function is also called, and inside sample function we have another variable x. So what are auto variables? So actually there is a storage class called auto, okay, or automatic storage class. So the keyword for that storage class is auto. So when we write some variable, let's say int a, okay, so this a variable is actually associated with auto storage class. So any variable which has no class associated with it or no class is written against that, so that variable will be actually of auto storage class. So auto int a or int a are one and the same thing. So this is a auto variable. The same way int x is also associated with auto storage class. The variable which are like automatic variable or auto storage class variable, they are actually stored on the stack part of the process. So here I have shown the memory layout of a process. So what is a process? So for the time being, what you can understand that this program is actually a process. So here I will use the program and process terms interchangeably, but there is a subtle difference between those two terms. For the time being, let's understand process and program as one and the same thing. So any program or the process is actually stored inside the memory that you know, and that program is actually divided into the main four sections or the four parts. So one is the text section, one is the data section, another is the heap, and last one is the stack. And between the stack and the heap, there is a part called shared library part. Okay, so inside the text section, this code will be stored. In data section, all the data which is getting used by the program, that is stored. Inside heap, some dynamic memory allocations are done, and inside stack, all the local variables which are present inside the functions, they are stored. Okay, so this int a is a local variable, and you can also say this is of auto storage class. So this a variable and this x variable, they will be stored on the stack. Okay, they will not be stored on the data part, they will be stored on the stack part of this process. So here you will have x equal to 30, and the same way you will have a equal to 10. So now first let's see this third statement, and then we will see the second statement. So third statement says variable which have the register storage class, they are not stored inside the registers. Okay, so let's see why this statement is also false. So here you can see I have used the register keyword. So this is the another storage class. Okay, so when we use register storage class with a variable, so what does it mean? It means that variable will be stored inside the register, but this is not a compulsion. That variable may be stored inside the register or it may not be stored inside the register by the compiler. So when the compiler will be compiling this program, okay, and it will be converting that program into the executable file or the any exe file, okay, so at that time the compiler will reserve space for this a. So this a can be stored inside the registers, but it can also be stored inside the memory, as automatic variable are also stored inside the memory only. So when we are saying memory, that means we are saying about the primary memory. So using the register keyword does not give any, you can say, compulsion to the compiler to store this a variable inside the register. But this statement is saying that the variable who has the register storage class, they are not stored inside the register. So this is absolutely false. Okay, they may or may not be stored inside the register. So let's see the second statement now. It says if a function has some static variable inside it, so that variable will be initialized every now and then whenever we are coming inside that function. So let's see what does it mean. So here you can see we have a main function, and inside main function I have a variable a, and I have called a function sample 2 times, and this is the definition of the sample function, inside which I have used a variable x. It is of type static. So this static is the another storage class. Okay, and I am printing the value of this variable, incrementing it. Okay, so if I run this program, what output can you predict? So you can see I am getting 30 and 31. Okay, so why it is giving me 30 and 31? Why not 30 and 30? So let's understand this. So this a is a local variable. Okay, so this a is 10. Now sample is called, so we will come here. Now we have int x equal to 30. So we have x and this is 30. Okay, so just for your information, this static variable will be stored inside the data section. Okay, so this static will not be stored inside this stack. Only the automatic variables, they are stored on the stack. Okay, now next line we are printing this x. So our output will be 30. Now we are incrementing this x. So this x will be incremented to 31. Okay, so now when we will go out of this sample function and we will come here, that is to the next calling of the sample, then this x will not be deleted from the memory. That means it will remain there. Why? Because the lifetime of the static variable is till this program does not end. Okay, so till this program does not end, this x variable will remain inside the memory with its all updated value. So when we will come to this next sample function calling, we will again come here, and now what will happen? We will not read this line or not execute this line. The compiler will directly come here. Okay, so it will just say what is the value of the x. So it is like 31 that was updated in the last calling. Okay, so 31 will be printed now, and now this x will also be updated inside the memory 32. Okay, so now we will come here and we will return 0. But if sample is called again, then our next output will be 32 due to this printf or due to this x equal to 32. Okay, so in this way we have seen that this static line, it is actually read only for the first time when we enter inside this sample function. After that we will not read this line, we will just come to the next line. So that's why this statement second is false. That is, static variable will not be initialized every time whenever we are coming to that function. Now let's see the last statement. It says global variable, they cannot be used in another function within the same file in which they are originally defined. So it means, let's say we have some program, let's say hello.c, and we have some global variable, let's say int a, and then we have some functions. Okay, some main and some another function. So it says that this is our original file. Okay, and these are the function. So it is saying that this global variable cannot be used here and here. So this is absolutely false, because if it is correct, then why we are declaring this global variable here, or what is the use of the global variable if we cannot use inside this file, inside these functions. Okay, so that means this statement is absolutely false. So I hope you have understood the explanation for all these statements, and if you have any comment or query, please write down into the comment box and I will answer them. And do not forget to like and share this video. So now let's move to our next question.